Hey folks, how is everybody doing? I hope you're doing well. In this demonstration, I'm going to talk about bending metal. And so there's a lot of different ways, obviously, to bend metal, and some are better than others depending on your application. Most of the metals that we use in this studio are quite soft. So a lot of times you can literally just take that piece of metal and bend it in whatever direction you want to bend it. Okay, if you just bend it with your hands like I did, you're going to get a pretty pronounced curve. Okay, typically what I prefer to do if I'm bending this piece of metal and I want it to be a specific shape, I'll go and find something that is that shape and bend it over that. Downstairs in the basement, we have all kinds of different sizes of pipe, different diameters of pipe. I've collected those over the years because it's a really good way to get a uniform diameter for your work. And so if I need a whole bunch of things bent to the same curve, I'm going to bend them over the same piece of pipe in the same spot. A better way to bend something is to either clamp it in a vise or clamp it in a brake. I'm over here at the small mounted vise, and I've drawn a line on my piece of metal. I used the square to draw this line, so it's a perfect 90-degree angle. Now, if I just take my metal and clamp it into this vise, I risk marking up the piece of metal that's in there. So what I'm going to do first, and you may notice this on a lot of the tools and vices, is I'm going to put some masking tape on the jaws. I'm just patting these jaws just a little bit to protect my piece of metal. Okay, so from here, I am going to carefully line up my line with the jaws of the vise. Now I can very simply just bend. Now that's a bit sharper than the ones that I did, the bend that I did with my fingers, but I can make it even sharper by taking the rawhide mallet and giving some nice little taps. You want to use the rawhide because I don't want to mark up my piece of metal here with hammer dents. And so I can make little adjustments, but you still see that there's a bit of a curve. Now, if I want a really sharp 90-degree bend, I have to do something else. I have to do what's called scoring and bending to get this sharp line. To score my line, basically what I'm going to do is I'm going to use this cutoff wheel to cut into my metal a bit. And what that cutoff wheel is going to do is it's going to create a groove in my metal. And the cutoff wheels are in these little white boxes in the drill bit drawer. And we need to use one of these screw top mandrels. Okay, the screw top mandrel looks like this one. It doesn't have a cutting wheel in it. And so the screw top mandrel is a pretty handy tool. You can use it for a lot of different things. We have these little stone grinding wheels. They say heatless grinding wheels on the package. Do not believe that one bit. These create quite a bit of friction, which creates quite a bit of heat. So what happens when your disc breaks? This can be one of the more annoying things with using these things. So what I need to do is I need to unscrew the screw that's at the top of this mandrel. But if I put this screwdriver, and we have to use this screwdriver, this little purple painted stubby screwdriver has been sharpened and manipulated so that it fits into these screws. We don't have another screwdriver in this studio that does this job. So this stubby screwdriver should never leave the flex shaft area. What I need to do is I need to put the chuck key into the chuck. That's going to prevent the flex shaft from spinning while I unscrew. And then from here, I'm just going to unscrew. I'm going to take out a new cutting disc. Going to put the screw in, and then I'm simply just going to hold this with my thumb on the screw, and then it threads itself on. Do not use the screwdriver to tighten this screw. It'll be too tight. Just holding your thumb on there makes it plenty tight enough. If we use the screwdriver, a lot of times the screw gets stuck in here and we can never get it out again. And so if that's the case, then the mandrel is shot. So to cut this, basically what I'm going to do is I'm going to hold the, well, first I need to obviously put the mandrel in and make sure it's straight. But I'm going to hold the handpiece extremely firmly. I need to hold on to this because the last thing you want is for that to jump out and skate across your metal, because the gouges that this will create are extremely hard to get out. So hold on to it really nice and firm. The other thing is that I've used a fine Sharpie to give me a line. And I've used the square to make sure that that line is perfectly 90 degrees. If you use the fatter Sharpie, you could start at one end of your line and end up at the other. And that could make your cut almost a degree or two off. If you're bending this around in 4 ways and one of those is a little bit off, your walls won't match up when you go to put this thing together. So if you're making like a really boring square box and you want those walls to be really nice and straight, use a fine Sharpie to get your line. I'm going to cut with a high rotation speed. So unlike drilling where you want the rotation to be nice and slow, I'm going to use a higher speed for the rotation. Okay, so I am right-handed, so I'm holding the handpiece in my right hand. If I'm holding the handpiece in my right hand, the disc is gonna basically rotate. It's gonna wanna go away from me. So I want to cut into that rotation. Okay, so I'm going to pull towards me if I'm holding this in my right hand. If I was a lefty, I would go the other way, where I would go away from myself, because you always want to go into the direction that it's cutting. So the very first cut, I need to be really, really careful, and I need to follow my line as precisely as possible. And now that I have a groove, I can move a little bit quicker. I should have mentioned earlier that of course, always eye protection. Okay, I am wearing my glasses. These little cutting discs have a tendency to just break and fly. And you know, I wouldn't want an abrasive cutting disc going into my eye. So what I've done is I've cut, I'm not quite halfway there. Now I see a little bit of a divot right here on the back. So that means this section, probably about a third of it, is cut to the degree that it needs to. But up here at the top and at the very, very bottom, I need to cut a couple more. And you want to go until you can almost see that groove the whole way across. Okay, so I'm pretty satisfied with what this looks like. All right, so I'm over here at the dry erase board, and basically, if you think about this, if this is a really zoomed in view of the thickness of my piece of metal, basically what I have done with that cutting disc is I have cut a groove in that metal. I've created a weak spot right here intentionally, because when I go to bend this, it's gonna want to bend right here. However, I have a problem. If I was to bend this right now, this corner and this corner would hit into each other. So I would essentially get something that looks like this, where this piece wants to stretch because that corner and that corner have hit each other, and then you're gonna break that thing on the bottom there. And so what I need to do is I need to get my square file out of my needle file set, and I need to remove material so that I have a V-shaped channel. Remove that material, so then I will end up with something that looks like this. So I've got my square file out of my needle file set. I don't know if you can see those corners. And so from here, I need to make sure that I'm holding the file so that it's going to create a V-shaped trough. Okay, so if you imagine this square object is my file, I need to hold it so that I'm filing on the corner. You may have seen me struggling just a little bit trying to file this because I have to hold on to it. So what I've done is I've C-clamped a piece of scrap wood to the table. I put 2 push pins into that piece of wood, and now I can file a lot easier. Okay, so when you're filing, you really want to focus your attention on the middle, okay? You're gonna get the ends. It's just natural. So you really want to focus your attention on the middle. Also, be careful how much pressure you're pushing down on the file. Files are very brittle, and they don't really flex too much. And so, try to save the life of our file. So I have a pretty pronounced line that I can see on the back side of this. You really only have one shot. If you didn't file enough and you go to bend it and it wasn't quite there, you're not going to get a full 90. And if I try to flatten this out, I'm not going to be able to. It's just going to break. So super, super easy. Boom. There is my 90-degree, nice, super sharp corner. Now this is super weak. Super weak. I've taken, probably 75 to 90% of the material away from the thickness of this sheet of metal. So what I should do is I should put flux on this line, put a piece of hard solder at the top and a piece of hard solder at the bottom of this, and try to flow solder into that corner to reinforce it. Because this is not going to take very much abuse at all. So another really cool thing that you can do with scoring and bending is I can score on a curve. Now if I really carefully cut this curve out with the cutting disc, it's going to remove a little bit more material than just cutting a straight line, because the cutting disc doesn't really want a curve. It wants to go in a straight line. So by turning it, I'm going to be opening up that a little bit, because I'm not going to be able to file this. So I'm not going to get a super, super sharp bend out of this, but I can cut on a curve. Okay, so I can see a faint impression on the back side of this. And from here, I'm just going to fold . So I have these two planes at a 90-degree, and then essentially I have this scalloped shape that's in the middle, because I was able to score on a curve. Now you can score multiple curved lines. You always though have to keep in mind that whatever metal is on the outside of that curve, it's going to have a convex bend, right? Whatever metal is on the inside of that curve is going to have a concave bend, okay? What you can't do is have two parallel curved lines. That's just not going to work, because if you had a parallel line, the metal that's on the outside of the line on one side wants to be convex, and the metal that's on the inside part of that line wants to be concave. There's a ton of really cool things that you can do with curved scoring. You know, you can basically whatever template you decide, you can start to score things and do some really interesting components. You can score things deep. Okay, so this is scored here, here, and then here. You can score things very shallow, okay, where it's just going to give a faint definition of that. You can score an S shape into something. Now this is a piece of metal that was hammer textured before I scored it. Okay, and it gives this nice little peak going across there. You know, do you want a scalloped corner box or just a boring square box? One of the great things about scoring and bending is I can use the manila folder to basically do whatever I want my metal to do. First, I'm just going to cut a more manageable piece of paper here. Okay, so imagine this is that strip of metal that I'm going to use. I can take my square give myself a line. Now, if I line up my ruler, this time if I take my X-Acto knife and I hold it upside down, I don't want to cut this line, I want to score this line. So I'm going to hold it upside down and just score that line. This piece of paper is going to want to bend along that scored line. Okay? I can get the compass out . And I can basically practice any of the forms that I'm thinking about. I can practice any of the forms that I'm thinking about making out of the manila folder first. That way you can adjust scale easier. You're not committed to the cost of all the metal, and you can see what this thing is going to look like in real life.